Building a PC is a rewarding process, but the configuration that follows assembly transforms these individual components into a cohesive system. Before starting, gather the necessary tools: a Phillips head screwdriver, your compatible parts, an OS installer on a USB, and a clean, flat workspace. Safety starts with your person and environment. Remove any loose jewelry and clear clutter from the assembly area to prevent damage. You must also manage electrostatic discharge. Ground yourself by touching a metal object before handling sensitive parts to prevent static shock. Skipping these preparation steps is the primary reason new components fail before the system even reaches its first boot. Your first task is to verify that your processor matches the specific socket type on your motherboard. CPU contact pins are extremely delicate. Handle the processor by its edges, avoiding contacts to prevent oil or physical damage. With the motherboard outside the case, align the markers on the chip and socket, then lower it without force. It will seat naturally. After mounting the motherboard on its standoffs inside the case, begin connecting your internal data cables. Press each connector firmly until you feel a positive click to ensure a stable connection. Precise alignment and the proper use of standoffs prevent electrical shorts, protecting your investment during the physical assembly. When you connect your monitor, ignore the vertical motherboard ports. Plug your cable directly into the horizontal ports on the graphics card to ensure the system uses your dedicated hardware for the display. Flip the switch on the power supply and press the power button. The internal fans spin up immediately as the system begins its power-on self-test. If the screen remains black, check your motherboard's Easy Debug LEDs. These lights identify if there is a failure with the CPU, the memory, the VGA, or the boot drive. This initial boot serves as a diagnostic checkpoint, confirming that every hardware component is communicating correctly with the motherboard. Tap the Delete or F1 key during startup to enter the BIOS menu. Check the system summary to confirm that all your installed RAM and storage drives are detected. Monitor your idle CPU temperature in this menu. For most modern builds, it should stabilize around 40 degrees Celsius. Many users don't realize that high-end RAM modules actually run at slow, standardized default speeds out of the box. To reach the memory speeds printed on the box, locate the XMP menu for Intel or EXP for AMD and enable it. This chart shows the significant increase in data transfer rates once the correct profile is applied. You should also be enabling resizable bar. This setting allows your CPU to access the entire frame buffer of your GPU simultaneously, which can lead to higher frame rates in modern games. Correctly configuring these two BIOS settings ensures your PC operates at its rated specifications, rather than staying throttled by safe factory defaults. Save your changes and proceed with the operating system installation. Once Windows is running, install all available updates and flash the latest BIOS version to ensure your system is stable. Use your motherboard's utility software to fetch the necessary chipset drivers, then download the latest official drivers for your graphics card from NVIDIA or AMD. To verify the integrity of the build, run a benchmarking tool alongside a monitoring utility like HWInfo64. Under 100% load, your CPU temperature should plateau between 60 to 70 degrees Celsius. As this graph demonstrates, a successful test shows temperatures flattening out well below the thermal throttle limit. If the system completes a 10-minute test without crashing, you have confirmed that the PC is structurally sound and thermally capable of handling heavy workloads. Passing that intense stress test without any issues means you have successfully built a stable, high-performance custom machine. From here, you can focus on personalization, adjusting your RGB lighting, setting custom fan curves, and downloading your software library. Congratulations on finishing your brand new build. If your temperatures were higher than expected during the test, watch our next video on PC airflow optimization to improve your cooling.